Okay, so on your sheet, force problems with constant velocity or accelerated motion, we asked you to do numbers 1 to 7. So number 1, a net force of 25 newtons is applied to a cart which weighs 125 newtons. So draw your box on the surface, and it says a net force of 25 newtons. So this is your F net in the x direction, right? So they're not saying you're pushing with 30 and friction is going back with 5. They're already doing the math for you, and they're saying the net force is 25 newtons. Acting on a cart that weighs 125 newtons. So they're telling you Fg is 125 newtons. And why do we care? Well, because they want the acceleration, and to get the acceleration, F net equals ma, you need m, because it's going to be F net divided by m. And we can get our m from this Fg, right? Because we know Fg equals mg. So m equals Fg over g. So m equals 125 newtons divided by 9.81 meters per second squared. So m equals, you get 12.7421 kilograms. And so then you take that up here and you do 25 newtons divided by 12, there's a decimal there, sorry, 12.7421 kgs, and you end up with an A of 1.962 meters per second squared for number 1. Number 2. What force must be applied to a 60 Newton object? So again, they didn't say the word weighs this time, but if the object's 60 newtons, not 60 kilograms, that's your Fg. And you're going to have to find your m, exactly the way we did in the earlier problem. Fg divided by g. So 60 newtons divided by 9.81 meters per second squared will give you an m of 6.1162 kgs. So if you want 6.1162 kilograms in here. So going back to the question, it says accelerates it at a rate of 3 meters per second squared. So A is 3 meters per second squared. If the force of friction is 5 newtons, and it wants to know what force, F, must you put on it. So friction's going back, and we're looking for this applied force. A lot of people call it F applied. When there's just one, I just call it F. If there's 1, 2, 3, then I call them F1, F2, F3. But you can call it FA if you want for applied, but I'm not going to, but don't stress if you do. We don't actually have to do some of the forces in the y direction here because they told us our friction. The only time we do some of the forces in the y direction is to get our Fn so that we can get friction. But since they already told us friction, we don't need to do it. We can just do some of the forces in the x. And so we have F minus friction is equal to max, and we're looking for F, so take your friction over. So F equals max plus friction, and now fill your numbers in. So F equals m, we found to be 6.1162 kilograms. A, they told us, was 3 meters per second squared, plus 5 newtons, 18.3486, and then plus 5. So this should be 23.3486 newtons. Number 2, done. Number 3, a 5 kilogram box is pushed along a horizontal floor by a force of 25 newtons. So this time they're actually telling us the mass, a 5 kilogram box. So put my 5 kgs in there, is being pushed along the horizontal floor by a force of 25 newtons parallel to the floor. So this is my F, 25 newtons. force of friction, which opposes this motion, is 10 newtons. So friction going backward, 10 newtons. We know there's going to be an Fg going down and Fn going up. If the box starts from rest, so Vi is 0, what will be its speed after 5 seconds? Delta t is 5 seconds, and we're looking for Vf, but first we have to find A in the x direction. Again, we don't have to do some of the forces in the y because they gave us the value for friction. If they'd given us the coefficient, we would need Fn and have to do some of the forces in the y. But because they gave us friction, we can skip that first step and the second step, and we can go right to some of the forces in the x. And in the x, we have our F, the 25 newtons, minus our friction is equal to max. And we're solving for A this time. So x is equal to F minus friction over m. And for those of you that are not yet into the habit of carrying your letters, rearrange for your unknown before you fill any numbers in. It'll be much easier, and as the questions get more complicated, you will be happier. So 25 newtons, whoops, except I missed the 5. 25 newtons minus 10 newtons divided by 5 kilograms. On the top, you get 15. 15 divided by 5, Ax is 3 meters per second squared. And now you want Vf. So you have A, Vi, Vf, so you're going to use A equals Vf minus Vi. Over delta t, it said it started from rest, so Vi goes to 0. So Vf equals A delta t. So Vf equals 3 meters per second squared times 5 seconds. So Vf equals 15 meters per second. Number 3 is done. Number 4 says, how long does it take the net force of 100, sorry, lost the question, I was reaching for something. How long does it take a net force of 100 newtons acting on a 50 kilogram rocket to increase its speed from, okay, so we have a net force again, F net is 100 newtons. The mass of the rocket is 50 kilograms, and it says it's increasing its speed, Vi, from 100 meters per second to Vf 150 meters per second. And this time you're looking for delta t. Don't even have to do any sum of the forces to get our F net. We just know F net equals ma, so A is going to equal F net divided by m. So 100 newtons divided by 50 kilograms gives us an A of 2 meters per second squared. And now that we have that, solve for your t. So A equals Vf minus Vi over delta t. So delta t equals Vf minus Vi over A. So 150 meters per second minus 100 meters per second over 2 meters per second squared. On the top you get 50. 50 divided by 2. The time should be 25 seconds. Number 4, done. Number 5 says, what braking force is needed to bring a 1,500 kilogram car moving 30 meters per second to rest in 5 seconds? All right, so what's going to mess you up here are the forces acting on this car. So there's going to be Fg going down and Fn going up. And if you're braking, then the braking force is acting opposite the direction of motion. And there are no other forces acting on the car. There is no forward force here. If you want to stop a car, don't put your foot on the gas while you have your foot on the brake. So there's only a backward force. And so it says the mass of the car is 1,500 kilograms. And if you got stuck on this one, I bet it's because you had a forward force and then you didn't know what it was. But that forward force doesn't exist. It says the Vi is 30 meters per second. It says you're bringing it to rest, which means Vf is 0 meters per second. And you're bringing it to rest in 5 seconds.